Everyone, let's take a look at number 6 in section 3.1. We're going to use the limit definition to calculate the derivative at z equal a of the linear function k of z equals 15z plus 13. Okay, so they got a lot of variable change that maybe you're uncomfortable with. Instead of the variable input variable being x, they've got z for the input, and the name of the function is k instead of f or g. Okay, so just get used to changes of variables. It happens in other courses as you continue your studies. So this is k is the function, z is the input variable. So we're going to use the limit definition. What's that going to look like? And I've got it actually wrong, but let's see. K prime of a will be the limit as h approaches 0. And even I was led astray. It's not f, but it's k. This is k of a plus h minus k of a, right? So instead of f, we're using the function, in this case, k. So that's my k, sorry. All divided by h. Okay, so what is k of a plus h? Well, I'm going to replace z. Z is the input variable with a plus h. So it'll be 15 times the quantity a plus h plus 13. There is k of a. So this right here is k of a plus h. And this here is just k of a, right? Just replace z with a, okay? All over h, okay? Now, granted, if you plug in h equals 0 right now, you're going to get 0 over 0. You should be able to see that. But let's simplify up top. If I distribute the 15 over the a plus h as I should, I get 15a plus 15h plus 13. And then be careful, distribute this negative sign through negative 15a minus 13. Look what happens up top, 15a minus 15a, 13 minus 13. All we're left with is 15h divided by h. That simplifies to 15. Now, what's the limit as h goes to 0 of any constant? It's just the constant, right? So there's our limit. There's the limit, 15. Now, if we've talked about this, maybe you've already remember us talking about this, but after we did the limit definition, we looked at these type functions. This is just a linear function, and we know the slope of any linear function very easily by looking at the equation, right? It's the coefficient of the independent or input variable. So its slope is 15. And the derivative is the slope of the function. If it's a linear function, it's just equal to the slope of that line. So it's easy to know now to go right to here, but they are asking for the limit definition. So on a test, if I ask for the limit definition, you have to show all the support, even though you might know what the answer is supposed to be by taking the derivative with any shortcut rules that we learn. Okay, hope this is helpful on this one.